Now we will have to work on example 1. For the function graphs below, illustrated as figure 7-2a, letter A, identify the kind of function it is. Letter B, on what interval or intervals is the function increasing or decreasing? Which way is the graph concave? From your experience, describe something in the real world that a function with this shape of graph could model. Letter D, find the particular equation for the function given that points 5, 19, and 10, 6 are on the graph. And letter E, confirm that your equation gives the graph in figure 7-2e. Okay, so let's take a look at the function. So this is the function. Okay, we are about to answer letter A. Identify the kind of function it is. So as you can see, this is a linear function. So our answer for letter A is that it is a linear function. It is a linear function. How about letter B? On what interval or intervals is the function increasing or decreasing? In which way is the graph concave? So let us examine the graph again. As you can see here, you are actually seeing a line. It's a line segment, but when you put an arrow on both sides, it extends in both directions unlimitedly. So this line is decreasing at a certain point, all over the point itself. So letter B, it is decreasing continuously, so decreasing on its entire domain. Okay, decreasing over its entire domain. Its domain. Okay, and what is the domain of this linear function? If you, as I have said, if you are going to extend the points on both sides, this would be to eternity. So it's an unlimited domain. So the domain here is from negative infinity to positive infinity. But of course, if there are certain conditions, then the domain would change, such as if you apply certain intervals or domain restrictions. Letter C, or I think we're not yet finished with letter B. Which way is the graph concave? You can see that there is no inflection or there is no curvature. It is entirely a line, and it doesn't have a graph that looks like this or looks like that. Therefore, our graph is not concave up or not concave down. It does not have any concavity over its entire domain. However, it tends to decrease over its domain. So does not have concavity. It's not concave up or concave down. It does not have any concavity. Okay. How about letter C? From your experience, describe something in the real world that a function with this shape of graph could model. So let us take again a look at our graph. There is an example which could indicate a decrease. Any real life situations that indicate a decrease over time could be taken plausibly as an example. For instance, we have the exponential decay, or the decay of a certain radioactive material. So any model that has increasing trend over time. So anything, you could have the exponential decay, wherein we could take into account a carbon atom decreasing over time. So that is in a way an example, a case for this type of function, a decreasing function. Letter D, find the particular equation for the function given that points 519 and 106 are on the graph. In solving this problem, first we have to acknowledge the general form of a line. We have already assumed that this is a linear function, therefore we have to convey the general form of a line, which is either y is equal to mx plus b or y is equal to ax plus b, where our a is the slope and our b is the y-intercept. So whichever of the two general form, mx plus b or ax plus b, could be acceptable. So b is the intercept, specifically the y-intercept. So let's try to note it here. It's the y-intercept. Okay, we are given 2 points here. So let's specify the points. We have point 519, and point 2 is equal to 10.6. Now, acknowledging the given general form for a linear function, so let us have some, okay, let's put it here. We have the first function. Okay, we are going to substitute our x and y values. These are our x and y values, by the way. Okay, this is our x and this is our y. This is our x and this is our y for these pairs of points. So the first thing that I will have to do is to substitute my x for this point here to the general form of a line, which is equal to y is equal to ax plus b. So let us try that one. So we have 19 is equal to a times 5 plus b. And on the second part, we have 10 on 6, so we substitute x for 10 and y for 6. So we have 6 is equal to a times 10 plus b. Now you could see that we have two equations. We have equation 1 and equation 2, and therefore we are presented with two unknowns also. So remember that to find, I need a solid line. Okay, to find the two unknowns, you must have two equations, right? Okay, so we could use the addition property for two unknowns. So we're going to use the addition, and that means that we're going to multiply -1 here. So -1. Okay, and then we're going to add the bottom and the top to see what's going to be the sum. So in this case, we have 19 minus 6, so that gives us 13. Is equal to A5, so that's 5A, minus 10A will give us -5A. And B minus B will just be equal to 0. So, therefore our 5A or our A would then be equal to 13 or negative 13 over 5. Okay? Now, how do we solve for the B? So we have here. And my B is, I have my A, so I will just substitute my A to any of the two equations given. So I will substitute it to 1. So substitute to 1 to the first equation. So we will have 19 is equal to A times, okay, my A is equal to negative 13 over 5. So negative 13 over 5 times 5 plus B. And then from here I could solve my B. So we will have 19 is equal to negative 13 plus B. And my B is going to be 19 plus 13. So my B is equal to 32. Therefore, my answer would be, what is my answer? I have my A, so y is equal to ax plus b, so y is equal to, my A is negative 13, negative 13 over 5, okay, over 5x, and my b is 32, so plus 32. That is my equation for the linear function. And I'm trying to look over the whole solution, and we have on C, it says that we have an increasing. I'm being careless. Okay, so this should be decreasing trend over time. Decreasing trend over time. Okay, we are done with our function, and this is our function. So, what is the question again? For letter E, confirm that your equation gives the graph in figure 7-2A. In this confirmation, you could actually use your grapher to graph the function y is equal to negative 13 over 5x plus 32. But another way to solve that is to just create an axis, okay, a system of axes for x and y. So this is your y and this is your x, and then get the x and y intercepts. So the x-intercept of this function here, so let us say this is our function already, right? So we want to move this. Okay, we're going to move this on the somewhere upwards. Okay, so we could use the space below to confirm the graph, to get the graph of this function by getting the x and y intercepts. So let us do that. Okay, to get the x-intercepts, we have to let y as 0. So let y is 0. So when y is equal to 0, we will have 0 is equal to negative 13 over 5x plus 32, giving us a value of x which is equal to negative 32 times 5 all over negative 13. So this will give us a value of, if you have a calculator, actually we have a calculator here, so we'll make use of that, math tools and calculator, and negative 32, so 32 times 5 equals 160 divided by 13. I could just get rid of the signs because they are both negative. So negative divided by negative, taking note of the properties for algebra, that's equal to, for integers, I mean, that's equal to positive. So we have positive 12.3. And then if we are to get the y-intercept, what we will just need is the b. And our b here is 32. So y is equal to 32 when x is equal to 0. So having that, we could just sketch the graph. This is 32. That would mark our y-intercept. And also our x-intercept is 12.3. So that will be somewhere. So let's say here 12.3. So this is our x-intercept. Okay. And then let's just connect the 2 points together. So connect the 2 points together. We will have okay. Just connect the 2 points. So let's connect them. Okay, like that. And then okay. So we get a similar graph with this one. So they are similar graphs. Therefore, we have confirmed that the graph that was given in the figure is the same graph as you can see here. So they are similar. And the linear function here is y is equal to negative 13 over 5x plus 32. You could also use the matrix formula to find the two unknowns a plus b. But for the purposes of our discussion, it's very easy, or it's much easier if we use the algebraic way of solving a and b, and that's the method that I use in showing you the type of equation and getting the equation itself, the linear function equation itself. Okay.